Text chat is great, but real conversations have voice, tone, pacing, intent. What if your generative app could take audio in directly and respond in kind? That's where multimodal models step in. Hi, I'm Rob Folkrod, a lead technical trainer at Microsoft, and in this session, we'll cover developing a multimodal audio chat app. We'll deploy multimodal models that understand audio, build an audio chat application against it, then extend the pattern into a speech-enabled app. Let's get started with the session. Inside of Foundry, we have a huge collection of models. I think at one point in time we showed a slide that had something along the lines of 11,000 models at our disposal. It is only the tiniest fraction of those that could actually be used for speech-capable services. So one of the things that we want to take a look at are what are the models that can be used. And here, while this isn't the totality of the list, you'll see that we've gone in and sorted by inferencing tasks. And so in this particular slide here, we are looking for a couple of tasks, right? In this case, we are looking for speech to text. Right. And in here we see capability speech to text, right? And so there are a number like the GPT-4o mini transcribe that carry on that capability. The second of the inferencing tasks, just kind of reverse our way here, text to speech. And so you can search the Foundry for those inferencing tasks, which you'll find right over here, and we can get a comparative alternate, right, which is the GPT-4o mini TTS, or text-to-speech. Right. With those models, they have been optimized, they have been designed specifically for a number of language tasks, okay, such as transcription. The ability to pass in an audio file, a video, and say, from that, I need to extract the transcription from it. And the other direction is we've got someone who it needs to be listening in on that content, and sending it by way of text isn't great. So that's where we would reverse to text-to-speech. You can think of your GPS, how it reads out to you the next set of directions. That's some sort of model in there that's doing, whether it's a GPT model or others, there's something in there that's doing that text-to-speech capability. And we need to go beyond just simple turn left at the stoplight, right? Because in that case, we really don't care so much about, not a ton, about tone. We don't really care about inflection. We need clarity, but we don't really care about the rest of those things. But that's not true for all human interactions. And so many of these models also take into account the ability to give intent, to give emotion associated with them as well. So they're richer than just make the sounds that are appropriate. So inside of Microsoft Foundry, we would deploy one or both of those models. We would typically use a model like GPT-4o transcribe if we wanted to take in binary audio content and then have the underlying text as output. And we would use GPT-4o text-to-speech, TTS, as a mechanism to do the opposite, to take in text and then read that out appropriately. The output, again, is going to be a binary data that represents that audio output. What we're going to see right here is we'll take a look at doing both of these. We'll go search for those and deploy those two models. We'll then create an application that can synthesize speech, and then create one that will dictate what we are saying and get the responses back. Let's take a look. So for starters, let's hop into a Foundry project that we have built earlier. We're going to go into Discover. And let's swing to the model side of things. And one of the things that we have the ability to do is do a search based upon their inference task. What are the models particularly good at? Now, there's not an insignificant number of tasks that we have here, but if we dive down and take a look first at our speech to text, we'll check there. Swing back up, we will see we've got a number of models in which that's their forte. Now we'll go and grab a smaller one here. So we'll do GPT-4o mini transcribe. And we will deploy based on default settings. So we've got our speech to text. Now we're going to go back to Discover, back to Models, Inference Task, swing way down to Text to Speech. Go the other direction, back up to the top. GPT-4o mini text to speech, perfectly good one. Deploy, default settings. All right, now if we are looking at our build section as we are right here, and we just go into models, we do have our two that are ready to go, our text to speech and our mini transcribe. Excellent. Let's take a look at some code. So here we've already downloaded and gotten our projects up and ready, but one of the things that we do have to do is set up our environment variables. So I'm going to go into the AI toolkit. I was just in the UI. I probably could have copied them from there. We'll make sure that we have the right project set up. So we will switch to our 4790 project. We've got our models that are there. That's good. Right click, copy the endpoint. We'll just need the Foundry endpoint there. It's the same for both of them. And then we can dig into our environment. Right. So into our environment variable 1, there we go. We have our demo resource. Same thing, and save before I leave. There we go. And that's our, we knew the default name. And same here, mini transcribe and save. Now let's start with generate speech. Inside of generate speech, not a lot that we haven't seen already. In this case, we're going directly to the model itself. So Azure OpenAI and our default credential. And in this case here, we're setting up our token provider default credential, building the OpenAI endpoint, passing in the endpoint, the token provider version for this particular model. And built into the client, we just have some really nice, in the OpenAI world, some really nice features, including audio and speech. That has a function in it called with streaming response. Pass in the deployment, pass in the voice that we want. And what the voice is going to say is my voice is my passport, and some instructions that the large language model can look at. So speak in a serious tone. That is going directly to a file. So if we look up above here, yeah, we look up above, we built a little speech.mp3, so that should appear right in here when we're all said and done. So we're streaming out directly to that path, and then using play sound. So that should work. We go into generate. Let's do a Python generate speech. There we go.
My voice is my passport.
As I stomped over it when it spoke, we can open that file up. We can hear it one more time.
My voice is my passport.
You know, with all of the importance that it's warranted. Right, so going back again and taking a look, audio, speech, streaming response, just to start getting those bytes back as quickly as possible. And we just wrote them directly to the path. Then again, reading this back up, play sound. If we were to look the other direction, we already have a WAV file here. All right, let's play that one just so you know what you'll hear it again in a second.
Oh man, on the other side of the screen, it all looks so easy.
It does. Oh man. On the other side of the screen, it all looks so easy. That's what we're hoping for in terms of our response. So transcribe, Azure OpenAI in this case. Again, file path, but file path now to our speech wave. We'll play it ahead of time just so that we know what we are going to be listening for. And then, again, token provider, default Azure credential. We've seen that a number of times. We're building our Azure OpenAI client. And in this case, audio, instead of what we saw before, which was audio speech, we'll now have audio transcriptions. Create, pass in the audio file, and then the format for the output. Then we will just display those on the screen. So all of that looks good. Python, transcribe. Oh, let's swing over into the right terminal here. Try one more time. There we go. Transcribe.
Oh man, on the other side of the screen, it all looks so easy.
So that was the play. Now it's being sent to the model. Oh man, on the other side of the screen, it all looks so easy. It does look easy. This one's really not bad. All right, let's wrap this up. All right, let's see how all of you are doing. So of those two, can you remember now, which model can you use to generate text from speech? Right. Text from speech is going to be the mini transcribe. Then, which model do you use to synthesize speech from text? Right. There is the GPT-4o Mini TTS, or text-to-speech. Relatively straightforward process. We're seeing a lot of the same ideas used again and again. Deploy an underlying model, create the appropriate clients. Here we had a little bit of work to deal with the binary data that was coming back in our Python application, but use the appropriate models. Again, a TTS model when we're looking at speech synthesis, and a transcription model for speech to text. In the session, we crossed from text into voice. We deployed a multimodal model and built an audio chat app, and developed a speech-enabled experience. Thank you for participating in this Develop AI Apps and Agents on Azure course. I hope you enjoyed learning about multimodal audio chat as much as I enjoyed presenting the concepts and walking you through it. I encourage you to remain curious and continue exploring new capabilities. That's how we all stay relevant. There are many ways to continue your journey. I invite you to search for your next favorite topic at Microsoft Learn at aka.ms/learn.